welcome back to the stream. I know it's been a long time since the last video and lots of things have changed, but hopefully I'm going to get back into making videos regularly and trying out a few things I've been playing around with. So as you can see, I'm trying to do like live streaming for the channel. So if you ever want to check it out, it's on Twitch. I'll post a link in the description below on my channel for Twitch, so feel free to subscribe to that if you want. Hopefully this will be a way to get some live feedback on what we're doing, and you can ask questions as I do it, and we can dive into whatever topics that people would be interested in talking through. I'll try to still keep it to 30 minutes to an hour of stream time and cut up the videos accordingly, but it should be pretty fun. I also have a new mic stand, so it's big and right in front of me, so it'll be interesting to see how that goes. Hopefully y'all can hear me a little bit better now than before, so overall excited to get back into it. So last video where we left off was getting a token from Robinhood for your authorization to do other calls through them. We wrote some unit tests around it, some integration tests, all that fun stuff. So we were able to fully do that piece of our library. We're going to pivot from that for a few videos and talk through some database layer items and some front-end UI work. So for the database, I want to be able to store my token in a secure way. So then in my future calls, I can retrieve it from the database for my other calls. So each user has their own token for Robinhood, and I want to be able to inject into my code whenever I make another call a way to get the token. I don't want to store the token in memory in my code, so I'm going to utilize databases to do that. So I have logged into the AWS console. I've used the admin account. So we're going to do administration kinds of things. We're going to set up some security groups and maybe create the database table in this stream. We'll see how far we can get. But yeah, so AWS console with the admin account. AWS has a few different options for databases. They have relational databases, which would be RDS, and they have non-relational databases, and specifically DynamoDB. So it's a managed NoSQL database that is completely owned by AWS. It has lots of built-in features behind it that takes care of a lot of things for us. So it takes care of making sure your database is available and accessible no matter which region you're in. So it does some replications and things like that behind the scenes. It handles scaling, so as you get more and more data, it scales up the size for you. So it does all of that kind of database administration stuff for you without you having to do anything. So DynamoDB, definitely interesting choice for databases, and what I'll probably start with what we're doing. I'm not going to go into a lot of detail on designing out a database schema and what fields we need and what tables we need and things like that. I'm going to try to do whatever I need to do to get to the next step. So hopefully our database schema and table structures will grow organically as we figure out what we need. I don't want to spend a lot of time thinking of all the fields and all the use cases all right now. I'm just going to go with what we need and then build up from that over time. So we'll use DynamoDB as a database. For now, I know I want to store the credential token for each user. So our primary partition key would probably be a user ID or user account, and then we can add a sort key, so it'd be a composite key, and that'll probably be the brokerage that we are using. So for instance, there will be a object in our database for alt/ Robinhood, and then another one for alt/ E-Trade, alt/ whatever brokerage you want. So that should allow us to be able to do sorts and get the token back correctly based on that composite key. That should make it unique. This will probably also contain other like user account information, so username, things like that. Might include email addresses, first name, last name, whatever type of data that we would find useful in our application. So, all that said, one of the first things we're going to do is work on some security. So our application needs to be able to communicate with this database, right? So it's not going to allow anybody access to the database. You have to have special permission to get to the data. Similar to what we've done setting up the individual IAM groups and users, we'll do for database access. So what we're going to do is go to IAM, and we're going to create a new group for DB admins. So we'll go to groups, create a new group, DB admin. I don't know if you can have a space. DB admin. So the policy, this will be any database stuff, so it'll be segregated. So this account can only do database things. It shouldn't be able to do any other admin functions like managing users or managing EC2 instances, so on and so forth. We don't have a lot of databases. We're going to do DynamoDB. So for now, we're just going to add the Amazon DynamoDB full access. So this will allow reads and writes for any user in the group. So next up, that all looks correct. Create group, and we have a new group. Next up, we need to add a new user. So this user will be a programmatic access to the database. So the secret account and key credential will be used in our property files in our code to allow our code to access the SDK to access the database. All right, so I can dive into more detail if you all need on that. But for now, we're just going to go ahead and start creating this user. So username, we'll see, is DB admin. And we're segregated by the application. We'll say DB admin. Application. So this will say, if I look at the username, this would be something from the application, not a physical human user. So it's programmatic access. So this will give us an access key ID and secret access key to use for our SDK. So from our code to use to log in to do stuff. Add user to group. We're going to add to the DB admin group that we just created. We don't need to worry about keys. Review, everything is good. I'm going to pull this over to the other screen because this will give me the access key and secret access key. So all I'm going to do off screen is copy and paste that into a notepad. close, pull that back over, and there we go. All right, so just a quick recap. We created a new group for DB admins, so anybody that needs access, administrative access to databases, and they don't need any other admin access, can be added to the DB admin group. Then we added a new user to have programmatic access from our code to get to the database, and we've added them to the DB admin group that we created. And that should be all for our IAM setup. And I copied and pasted the secrets over to Notepad for use in our application properties later. So let's look at DynamoDB. So it kind of talks through and has a lot of documentation and support on creating tables and managing tables and all that fun stuff. Something interesting how DynamoDB is set up as far as pricing model goes is it does things in read and write units. You can get kind of really detailed on what that means. It's not just read and write operations per se. But yeah, it is in read and write units. So if you're interested in how the pricing model works, there should be documentation on their pricing and what they mean by read units and write units. They should give you some free units for the free tier. And we aren't going to be doing a lot of heavy reads and writes to our database with what we're doing right now, so it shouldn't be an issue. I think if you go over your limits, so you would say like how many read and write units you want to allocate to your table. If you go over that, I think it locks you out of doing any more operations. So that would be really bad if we're in production and we run out of units and then it just stops any database operations from happening. So, and I'll try to look that up and make sure that is an accurate statement, but I'm pretty sure that's what I recall. So our table name we'll say is user credentials. Without a space. So primary key, this will be a string, and we'll say user, and we'll add a sort key for the broker so they can have multiple, there'll be multiple objects based on the user and what brokerage that token is for. Right now it's just Robinhood, but I don't want to redo this when we add more brokerages into our system. So this should allow us to have separate objects for each brokerage along with the user to make it be unique. And this will be a string as well. So string, that looks fine. So we'll hit create, and in a couple minutes it should be set up for us. So we have the table name, primary partition key, and sort key. So this is what I mentioned before, read units and write units. We have 5 allocated. I think that's within the free tier amounts. and we don't have auto scaling. So if we have a spike of database operations within, I think, a minute, or it might be per second, I need to look that up, but it will lock you out if you go above that threshold. So a little bit on the layout overall. So items, this you can look at what all's in your table. So right now it's empty. There's no items in here. I believe we can add in items from here, so it doesn't have to come from application. It could come manually entered in here. So create item, user alt/ value for broker test. Hit save. Now we have entry in our database. So it does allow you to do things right within the AWS console, which is kind of nice. So let's see if I can go ahead and delete this. There we go. So we have an empty database. So yeah, so our database should be set up right now. So we should be ready for some Java layer code. So the next step, now that we have the database created, is to have our application be able to connect and use our database. So we'll probably create a service in Java. That service will probably have CRUD operations. So we want a method to create entries in the database, read, update, and delete. So your typical CRUD operations. We'll have properties in a application.yaml file that will have our access ID and our secret credential to give it access. And it should also have, I believe, the region that the table exists in and stuff like that. Then we'll have a model that represents our data, and we should be able to do reads and writes to it. We'll probably go ahead and add this into our wherever it went to, test endpoint. In here as a test. So we'll add in some tests to see if we can create, read, update, and delete from our table. And each one of those will be a test that we will inject in and make sure it works correctly. That would be considered an integration test because we're doing actual stuff to a database. We'll write unit tests on all that fun stuff. But yeah, so I think that is where I want to leave this video. So we are set up now from our AWS console to be able to do some Java level code with our new database. So with that, thank you for watching through the video. If you're again interested in joining any live streams, I have the Twitch channel in the description below. Feel free to subscribe and join in whenever I go live and ask any questions or chat with whatever you all want to chat about. Thank you all. Bye.